Happy Tuesday, 7th Accelerated students. What we're going to do today is we're going to start putting some pieces of what we've been doing together because it's going to lend us into something called systems of equations probably early next week. So in order to be able to do systems, graphing multiple equations or lines on one graph, we need to become experts at graphing one line. So we've been working on this a little bit here and there, but I want to go through and review something real quick with you. So when we write an equation, we need two pieces, slope, your m, and a y-intercept, your b. If the graph is proportional, we know the equation will be written in y equals mx form. Because if it's proportional, that means it's passing through the origin. Okay, and it's a straight line. However, if the graph is not proportional, that means that the equation will be written in the form y equals mx plus b. Because if it's not proportional, that means it will not pass through the origin. It will pass through a different number on the y-axis. So, and let's review these two. So the equations of horizontal lines, remember a horizontal line being left to right, the y value is constant because if you take a look, that line, if you spear that and think about it as an arrow, if you spear that through which axis would it go through? That would go through the y-axis. Therefore, all equations of horizontal lines will begin with y equals. And equations of vertical lines being up and down, okay? If you took this as an arrow or a spear, that would spear through the x-axis. So in the graph of a vertical line, the x value is constant. Therefore, the equation of the vertical line will always begin with x equals. So let's go through, and I'm not going to do each of these with you, but I'm going to get you the hang of answering these questions properly. So let's take a peek at number 1. To identify your slope on a graph, you want to find 2 points. Okay, I always identify the one on the y-axis where that crosses. If it crosses nicely at a number, that one's pretty quick and easy to pick out. The next point that's easy and quick to pick out that crosses the grid lines perfectly, I see is right there. Remember, your slope is your rise over your run. Now be careful here. Look at your y-axis. This goes up or increases by 2, and it goes over 2. Okay, so you really want to make sure that you look at the numbers on your axes so you don't get that piece wrong. So it goes up 2, over 2, rise 2, run 2, rise 2, run 2. 2 divided by 2 simplifies to a slope of 1. My y-intercept is where does this line cross the y-axis? Crosses the y-axis at positive 4. So my equation would be y equals, you can write 1x, remember you're just not going to see that as a multiple choice option. You'll just see plain x plus 4. The last question I want to ask, is this graph proportional? So what did we review up top? If it's proportional, it's going to be a straight line passing through the origin. This is a straight line. Does it pass through the origin? The answer is no. So this graph is not proportional, hence why we have a y-intercept other than 0. Okay, I want you guys to try number 2 and identify what is the slope, what is the y-intercept, what is the equation, and is this graph proportional? Okay, real quick. I chose these 2 points because they crossed perfectly and they were pretty quick and easy to find. So notice my slope here, it goes down 4 because it goes from -4 to -8. That's down 4, so -4 over 6. So if you take a look at what your x-axis went over, to 6. I'm going to simplify that to -2/3. My y-intercept, where my line crosses the y-axis, is at -4. So my equation is y equals negative 2/3 x minus 4. Is this graph proportional? No, because it does not pass through the origin. Okay, take a look at number 3. Really think about what your slope is. What is your y-intercept? Your equation? And is this graph proportional? Okay, so here, remember, horizontal line has a 0 slope. This kind of makes a z here. So we should be able to kind of memorize these by now. This is our 0 slope. If you wanted to just check your ratio to make sure you're right. So find 2 points. I'm going to use this point, and I don't know, the one next to it is just as equally easy. What's my rise here? It did not rise at all. It did not go up. It went up 0 over 1. When you divide that, it equals out to 0. So that's where that 0 slope makes sense. My y-intercept, it crosses the y-axis at 4. Okay, you do not have a slope, so it goes through, this line passes through the y-axis at 4. It does not have a slope. It has a 0 slope. Is this graph proportional? No, it is not proportional because it does not pass through that origin. Number 4, what is the slope of number 4? What is the y-intercept of this graph? What is the equation of this graph? Is this graph proportional? Okay, let's talk about a couple things here and how we did. Number 4, our slope on this graph is undefined. Let's talk about why it's undefined. So you don't need to write your ratio of why it's undefined, but I want you to understand where that comes from. So I just happened to pick these 2 random points. You can pick any points like I showed you. Your rise over your run, so your rise. So to go from this point to this point, I went up 4 over 0. I did not run any. 0. I did not go over. So when you put that in your calculator, you're going to get error. Okay, divide by 0, error. That's undefined. Remember, we've been talking about that for a couple weeks now. The y-intercept, do not write 0 here. We've talked about that a few times. Why? Because it does not pass through this y-axis at all. So we cannot put 0. If you do, that implies that it passes through right here, and that's not true. So you do not have a y-intercept. However, you do have an x-intercept, because this line passes through the x-axis. At which number? It passes through the x-axis at -6. So your equation would be x equals -6. Is this graph proportional? No. We should become good at this now. It is not proportional because it does not pass through the origin. All right, next piece. Let's take a look at number 5. This is a multiple choice question. Which of the following situations could be modeled by the graph below? So let's take a peek at our graph here. Even though there's not any words on our axes yet, what I want us to do is I want to identify a couple key pieces. So I want you to identify, so your y-intercept is at 100. Therefore, this is not a proportional graph. This means you're starting at 100, and because this line is a downhill line, this is a negative slope. Okay, so you can take a peek. Here's my next line that crosses perfectly. So it goes down 10 over, you can see that goes over to 3. So my slope is down 10 over 3. We don't necessarily, nothing can go into both 10 and 3, so I'm going to leave it like that for right now. I just wanted you to take a peek at these. It doesn't ask the question about that, but it does ask which of the following situations could be modeled by this graph. So situation A says Elena has $100 in her bank account. Every 3 days, she saves another $10 and adds it to her account. Situation B says Hunter weighs 100 pounds and his goal is to gain weight for football. He gains about 10 pounds every 3 weeks. In situation 3 says Dawn's pond is 100 meters deep, but her city hasn't received much rain. As a result, the pond level decreases by 10 meters every 3 days. Which one of those situations do you think best models this graph? I'm hoping you're answering letter C. Let's talk about why A and B don't make sense. So Elena has $100 in her bank account. So this meets the criteria that it starts at 100. That's good. Every 3 days, she saves another $10. So if she's saving another $10 and she starts at 100, your line would be going up 10 every 3 days. But instead, our line's going downhill. Remember, we talked about our slope being negative? So that one would not make sense. Situation B, Hunter weighs 100 pounds, so he starts at 100 pounds. That meets that criteria on the y-axis. And his goal is to gain weight. He's going to gain about 10 pounds every 3 weeks. So if he's going to gain weight from 100 pounds, his line would go up in that situation. But that's not the case in this modeled graph. It goes down. He's not losing weight. So that one wouldn't make sense. Dawn's pond is 100 meters deep in situations 3. So it's starting at 100 meters. And they haven't received rain, so the pond level is decreasing, going down 10 meters every 3 days. So what axis word would go over here? This would be down 10 meters. So these numbers must be talking about meters every 3 days. So these numbers on your y-axis or your x-axis are representing days. Okay. So take a quick peek at number 6. If you had to create your own real world situation that could be modeled by a graph at the right, what do you think you could come up with? Which scenario below would be the one that could match this modeled graph? Okay, so we're going to look at this multiple representations. So sometimes you are going to be given a verbal description. Sometimes you'll be giving information in a table, in an equation, or a graph. They're all linked to each other as we've been practicing in the last few weeks. So here I'm giving you a verbal description. A baby giraffe measures 6 feet tall when it is born, and it grows an average of a half a foot each month. So let's take a look here. So our equation. So it's the same equation that we've been kind of talking about, our y equals mx plus b. So what does the baby giraffe's height start with? It starts with 6 feet tall. So that's where we begin on our y-axis is 6 feet tall. So I'm going to plug in positive 6 for our y-intercept. And it grows an average of a half a foot every month. So that's your rate of change. That's how much the giraffe is changing in weight. So that's your slope, 1/2 every month. So X must be 1/2, half of a foot every month, plus the 6 feet that it was born with, equals its total height. So let's talk about how this table makes sense. X value is your total months because the giraffe grows a half a foot each month. So at 0 months, guys, what do you think? If I plug in 0 here, 1/2 times 0 is 0 plus 6. What was the giraffe's height when it was born? At 0 months when it was born, it was 6 feet tall. So if we wanted to know what was the height of the giraffe at 1 month, 1 month, a half a foot times 1 is 1/2 times 1 is, anything times 1 is itself, plus 6, so a half plus 6. So at 1 month, the giraffe was 6.5 feet tall. And you could keep going and plug in all of your pieces of data here, but I think you're starting to see the pattern. Every month, he grows a half a foot. So half of 2 is 1, half. Okay, so now to graph this. So key pieces here. X was our number of months. Y-axis was our height of the giraffe. So on the y-axis, I'm going to label height. On the x-axis, I'm going to label months. Okay, so I did this for you. I kind of fast forwarded. I did 0 to, I extended it out to 10 months, even though we only went up to 6. And the height started at 0, went up to 10 feet, even though we only have data in our table up to 9 feet. But we could keep going if we extended our graph. So the giraffe's height started at 6 months, at 0 months. The giraffe's height started at 6 feet, excuse me. At 1 month, he was 6.5 feet. 2 months, 7 feet, and so forth and so on. And our height is in feet. It's important to note that as well. So that's kind of how we look at all these. Now you guys can answer questions on any of these. So let's answer the questions below. Explain how you found ordered pairs to create your graph. Okay, these ordered pairs, where did they come from? Your table is your ordered pairs. They came from X and Y. X, Y, X, Y. And these are all 2, 7, 4, 8. These are all ordered pairs that came from your table. Let's answer number 2. What is the slope of the graph? What does it represent? What is the y-intercept of the graph? What does it represent? What does the ordered pair 9, 10.5 represent in the context of the situation? So that's not graphed, but if it was to be graphed, what would it represent in this situation? And last but not least, if the giraffe is 12 feet tall, how many months old is it? What could we do to figure that out? Okay, let's take a look now. When I give you the equation, we're going to give the verbal description, fill in the table, and fill in the graph here. So y equals 1.5x plus 12. Well, let's take a peek at our graph first to kind of help us get a gist of what this is talking about. So the title is Joey's Pizza Parlor Cost. And the y-axis is the cost of a large pizza. So this is the cost of a large pizza. And on the x-axis is the number of toppings. So this is your number of toppings on your pizza. So now we can put this into context a little bit. So how much would a pizza cost if you got 0 toppings? So if you put 0 in here, right here, 0 toppings, 1.5 times 0 is 0. 0 plus 12 is $12. So it must cost $12 for a large pizza with no toppings. If you got 1 topping, the number of toppings are here. So if you plug in 1 times 1.5 is $1.50. So how much does it cost per topping? It costs $1.50. 1.5 times 1 topping is 1.5 plus the $12 for the large pizza. How much would a large pizza cost with 1 topping? Add those two together to get a total of $13.50. If you got 2 toppings, 2 times 1.5 is 3 plus 12. So a large pizza with 2 toppings would cost $15. 3 times 150 is $4.50. As you can kind of see, the pattern's going up by $1.50 per topping. Okay. So I filled in the rest of that for you. So we maxed out our table at a large pizza with 6 toppings would end up costing $21. So to go graph this, I'm just going to use these points. Number of toppings, if you had 0 toppings, your pizza is going to cost $12. If you have 1 topping, it's going to cost $13.50. 2 toppings would be $15. 3 toppings would be $16.50. 4 toppings would be $18. 5 toppings is $19.50. And 6 toppings would be $21, which would be kind of off our grid. So now we can give an easy verbal description. So a large pizza cost $12 plus $1.50 per topping. Okay, last one we're going to look at here. I didn't give you a verbal description, an equation, or the graph, but I gave you a table. So remember, this is our X, then our Y. And you can kind of see how that matches here. Your Y-axis is labeled weight in pounds and the number of watermelons. So a quick and easy way to start this, guys, is you could, if you're a graph person, you may very well see 5 watermelons weighs 6 pounds. 10 watermelons weighs 12 pounds. 15 weighs 18, 20 weighs 24, and 25 weighs 30 pounds. So guys, if you don't know what to multiply by, like we've been doing like we did up here, we plugged in 0 to X, and we multiplied that to give us our Y value, the cost of the pizza. If you don't know what to multiply by because we don't have an equation, what could you do to work backwards? We could divide. So I'm going to come down here for a second. 6 divided by 5, if you guys throw that in your calculator, what that means is you get 1.20. That means it weighs 1.2 pounds per watermelon. That's kind of like your unit rate. Remember, in 7th grade curriculum, we divide Y over X, and that's your unit rate. So it costs 1.2 pounds per one, and we have 5 here. So to double check that is 1.2 times 5. Let me throw that in the calculator for you. 1.2 times 5 is 6. So your unit rate is what we multiply by. And if you take a look back here, remember that's your unit rate per topping. In that case, this is our unit rate per watermelon in this case. So to fill in that, you multiply your unit rate by any X value, and you get your Y value. So what would we do for an equation here? Y equals, what's our unit rate? 1.2x. And it doesn't change by anything. So guys, if you take a look, if you were going to actually connect these points, it goes straight back through the origin. Therefore, you are not going to have a y-intercept here because it goes through 0. This is a proportional relationship. So the verbal description here is each watermelon at the Woodbury Watermelon Patch weighs 1.2 pounds. Okay, you guys are going to do some practice on this stuff today. Have a great rest of your Tuesday. I'll talk to you later.